In our previous class, we looked at describing both quantitative variables with plots and categorical variables with plots. Sometimes we had two variables and sometimes we had only one. Now we are going to look at different types of studies and sampling. An observational study, the researcher observes values of the response variable and the explanatory variable. So we're observing both the response and the explanatory variable. And that's done without anything being done to the subjects by the researcher. So everything is purely observed, and so that's why it's an observational study. So we might think of ourselves as a researcher as just being dropped into the universe or dropped into the study design, and we're observing everything. It's a very passive study. In an experiment, however, a researcher assigns certain experimental conditions or levels of the explanatory variable to subjects and then observes outcomes on the response variable. So this might be a drug trial. And we're going to say you're going to take either the new drug or you're going to take a placebo. And we control who's in which group. And so the new drug and the placebo, these are categorical variables. These are levels of the categorical explanatory variable. And then we're just going to observe the time to recovery or the amount of recovery or whatever is the response variable of interest. But in this case, we're controlling who's in which group. In an observational study, if we're looking at the relationship between smoking and lung cancer, it would be grossly unethical to say you're going to smoke so many packs of cigarettes per day and we're going to just observe whether you get lung cancer. We can't do that. So this would be an observational study. However, you're never going to convince me that smoking doesn't cause lung cancer, and over the many decades in which this has been studied, we've eliminated the many other variables that could be possibly associated with lung cancer. But we have not controlled if people smoke or not. We're just saying there is a strong enough association, and by elimination of other variables, we can see that there is a causal relationship. So in experiments, however, we can say causal association in an observational study cannot infer causation. So how do we get that causal relationship? Well, we have to do that via random sampling and then random assignment. So random sampling allows us to generalize to a greater population. So we cannot generalize study results to the population unless it's really representative of the population. And even if we use random sampling, it should be noted that we're not always going to get a perfect representation. So this is meaning that if we were to do this over and over and over again, on average, we'll have something that looks like the population from which we've sampled. For example, we should all be familiar through our U.S. history, or most of us will be familiar through U.S. history, of the Federalist Papers, which were used to promote the signing of the U.S. Constitution. So from Federalist Paper number 51, we have this excerpt. To what expedient, then, shall we finally resort for maintaining in practice the necessary partition of power among the several departments as laid down in the Constitution? The only answer that can be given is that as all these exterior provisions are found to be inadequate, the defect must be supplied by so contriving the interior structure of the government as that its several constituent parts may, by their mutual relations, be the means of keeping each other in their proper places. Without presuming to undertake a full development of this important idea, I will hazard a few general observations, which may perhaps place it in a clearer light and enable us to form a more correct judgment of the principles and structure of the government planned by the Convention. So if we wanted to estimate the average word length of this excerpt, I could have students choose 5 words from the passage and calculate the average word length for the 5 words. We'll call that method A. Then I can use a calculator to take a simple random sample, so SRS is simple random sample, of 5 words from the passage, and again calculate the average word length, and we'll call that method B. So here, method A, this is students choose. Method B, this is our SRS. The true average word length of all the words in this sample is 4.9 characters or letters. So this is the truth. Now, we are not measuring all of these words, so this word length, this true average word length, may be unbeknownst to us. So let's compare this. If we look at method A, we see that students tend to overestimate the truth. That's because bigger words tend to catch our eye. So we're less likely to sample words like it or the. We're going to see things like convention or inadequate or answer or constitution even. And so those words are going to be overrepresented in our sample of 5 words, and that's going to pull that sample mean when we're just picking what seems random to us in our samples of 5. However, if we have a simple random sample of 5 words where it's really just random and word length is not drawing us to those words, we're going to see something where we have a sample mean of 5.1 in this case, which is much closer to that true average. So the number, how do we do this? We would number the words 1 through 130. We would randomly generate 5 integers from 1 to 130, and we would skip repeats. We could do this with a calculator, we could do this in Excel or even Jump, so it's fairly straightforward. And the average of those estimates is close to the truth. This means our sample on average is a better representation of the population. Now we can see that some of our samples are kind of far away from the true population, but the average across all of these simple random samples is pretty close to the true mean. Unlike when the students are sampling, all of them are pretty far away from the population mean. We don't have any that are underrepresented. We say that method B, when we use simple random samples, this is an unbiased sampling method. So let's think about some limitations of observational studies. So we can do a simple random sample and do an observational study using that. There are still going to be some limits. So for example, many people believe that sugar makes kids hyper. However, if we were to actually do this experimentally, where we control the amount of sugar children get and then observe their hyperactivity, that does not really support that claim. So what are some possible confounding variables in this context? So let's first describe what confounding is. Confounding occurs when 2 variables are associated in such a way that their effects on the response cannot be distinguished. They confound us as to which effect is really occurring on the response, or they are confusing us as to which effect is really occurring on the response. So let's break this down in our sugar example. Our explanatory variable is sugar, and we believe that that has an effect on the response, which is hyperactivity. However, there are many possible confounders. Some may be just the traits of kids. Maybe sugar lovers are more hyper. Maybe it's situational. Maybe kids have more sugar on vacations, or holidays, or birthdays, and that's when we see them more excited. Maybe it's just because of the expectations of parents. So, we cannot separate the effect of these confounding variables observationally from the explanatory variable of sugar. But when we do this experimentally, we can randomly assign how much sugar children have and observe their hyperactivity. And that would be randomized across vacations, holidays, sugar lovers versus non-sugar lovers, and the expectations of the various parents. That is a benefit of what we like to see in randomized experiments. So to establish this cause and effect relationship, which we cannot do in an observational study unless we literally eliminate all possible confounding variables over time and many other observational studies, we have to conduct an experiment. Ideally, a double-blinded, randomized, placebo-controlled trial, and we'll define each of those terms in turn. So a double-blind study is something like we would often see in a pharmaceutical study or something that we would see in animal trials or something like that. So a double-blind study controls expectations for both participants as well as the researcher. So the participant does not know which treatment they're getting, and neither does the person monitoring the outcomes. So the person measuring the outcome and the participant do not know what treatment is received. In a randomized trial, this creates groups of participants as similar as possible, as similar and comparable as possible. By balancing out unwanted variables in variation. A randomized trial is accomplished via random assignment. This is not the same as random sampling. I can have a random sample and do an observational study. If I have a random sample, I can then randomly assign or randomize my subjects or my participants to different groups. That would get me an experiment. So randomized or randomization or random assignment is not the same as random sampling. Random sampling gets me my sample of participants. Random assignment or randomization gets me the groups or the treatments that those participants would be in. If I have a placebo-controlled study, it treats the subjects or participants, it's a little less clinical, in all groups the same, except for the active treatment this is necessary for blinded both single and double-blind trials. For example, we need a placebo when we want to measure the effects of a drug, because if a patient knows that they are not receiving anything, if they are in a drug study and they get a drug, and like a pill, versus a group that receives literally nothing, no pill, no shots, nothing, then the group that's in the group, and the patients who are in the group that don't get anything, then they know that they are not receiving a treatment. So that's why we invented the idea of a sugar pill or just a saline shot, because we want to know the effect, we want to measure the effect of the psychological impact of having received treatment versus the actual effect of receiving the medication itself. And that's the idea of the placebo effect. So sometimes just thinking that you're receiving something, the idea of receiving some treatment or being attended to, can affect outcomes. And we want to be able to measure that and the difference between that and the effect of the drug itself. So if we're measuring the efficacy of a surgery, people or animals or whoever is being treated, they will receive anesthesia, they will literally go under the knife, they'll receive an incision, and then they'll wake up, they'll have sutures and everything, even though nothing will have actually been done to them while they were under anesthetic. So this placebo-controlled idea is very important because we want to be able to measure the true effect of having received the treatment itself, as opposed to the impression or the perception of having received a treatment.